Hi everyone, so this is lesson 1 on solving equations. So here I have 3 things written down for you, and I've got 3 words here: equation, identity and expression. And I want you to pause the video and see if you can match up the equation, the identity and the expression. Okay, so hopefully you would have got them in this order. So the first thing we have here, this was an expression. We'll go through how you can identify them in a second. So the first one was the expression. The next one was the equation. And the last one was the identity. And the way you can identify each one, I'm going to write some little notes next to these. Firstly, an expression, in fact expressions, equations and identities all contain terms. So we've looked at terms before, haven't we, and we used bubbles to circle terms. So here I can circle the term plus 8 in this expression, and I also have the term 2x, which doesn't have a symbol, a positive or a negative in front of it, but we know that if we don't see anything, it's a positive. In the equation we have the 2x term, or positive 2x, we have positive 8, and we also have positive 20. So all of these things, equations, expressions and identities, are made up of terms, but you'll notice with expressions it's just made up of terms. There's no equal sign and no answer. So we could write here made up of terms, or made up from terms, made from terms. I'm going to put made up of terms. So made up of terms. An equation is also made up of terms. But we also have an equal sign and an answer. So made up of terms with an equal sign and answer. Yeah. And then an identity, you may have got that one because we have seen the identity symbol before. So an identity, it contains the identity symbol, so that's really easy to spot. And if you've forgotten what the identity symbol is, it's an equal sign but with 3 lines. So that's the difference between the 3. And we're just going to quickly look at identities for a second, because lots of people ask what's the difference between identities and equations, because they are really similar. One thing I just remembered is that a really easy way to remember the difference between equations and expressions, because often people get confused between the two, is an equation contains an equal sign, and we know that the word equals begins with EQ, and so does the word equation, whereas expression begins with EX. So that doesn't have an equal sign in it, so it doesn't begin with EQ. That's one way you can remember it. So we'll just look at identities for a second. So I'm going to put a little subheading here of identities. And we're going to talk about what they are, because when we're studying equations, there is a key difference between the two. So with identities, identities are true for any, and this is any, value of, now my identity that I wrote down that I'm going to work with has an x in it, so I'm going to write x. But if this identity had a, if it was 2a plus 8 is identical to 2 bracket a plus 4, then I would put a. But essentially the letter in the identity can take any value. It could be positive, it could be negative, it could be a whole number, it can be a decimal or a fraction. It is true for any value of x. So And I'm only using x because I've got x in this one. So we're going to take our identity, which is 2x plus 8. I'm just going to rewrite it here. 2x plus 8 is identical to 2 bracket x plus 4. And you guys have actually learnt the processes to create this identity. You've learnt to factorize, which would take us from the left-hand side to the right-hand side, and you've learnt to expand brackets, which would take you back that way. But anyway, so I'm going to just show you that this identity is true for any value of x. I'm only going to do 2 because our lesson's not really on identities. So I'm first going to take the value of, maybe I'll do this in another colour. I'm going to take the value of x equals 5. And I'm going to show you that this identity is true for this value. So over here I'm going to substitute 5 where the x is in both sides of this identity. Notice when I substitute the 5, I put it in brackets. Because if I was to just put 2, 5, that would look like 25, wouldn't it? But actually we know it's 2 times 5, which is 10. And we know that 10 plus 8 is 18. So that's what we get on the right-hand side, the left-hand side. On the right-hand side we have 2 bracket 5 plus 4. We know we must do brackets first by following BIDMAS. So inside the bracket 5 plus 4 is 9. And that also gives us 18. So we can see that this value of x equals 5 satisfies this identity because the left-hand side and the right-hand side both give 18. But I'm going to show you that you can take any value of x and this will be true. So if I take another value of x, I'm going to now take a negative number to show you this will even work for negative numbers. I'm going to take x as negative 2. And I'm going to show you that this works for that as well. So I'm going to substitute it in, so 2 times x, which is going to be 2 bracket negative 2 plus 8. That's the left-hand side, and on the right-hand side I'm going to have 2, and then inside the bracket we have x. I'm putting that in brackets, plus 4. Okay, now we'll work out what each side is equal to. So 2 times negative 2 is negative 4 plus 8, and negative 4 plus 8 is 4. And on the right-hand side of the identity, we must do what's inside the brackets first. So negative 2 plus 4 is going to be 2. And 2 times 2 is 4. So this negative number satisfies the identity. I want you to pause the video now. I want you to choose two other numbers, okay? And I don't want you to pick really nice, easy, obvious ones, numbers below 10. I picked nice, easy, obvious ones. I want you to try and pick some tricky numbers, some really high numbers, really large numbers, maybe even a fraction. Working with a fraction would be great, and you should get exactly the same on the right-hand side and the left-hand side. So that's identities, but equations, which we'll move on to now, are not quite the same. So the next subheading is going to be equations. Now equations are only true for one value of x, and we'll look at an example. So I'm just going to copy down the equation from the beginning of our notes, which was 2x plus 8 equals 20. And I'm going to show you that this doesn't work for all values. It will only work for one value. Oops, there we go. So I'm going to go with x equals 5 again. And I just picked that randomly. So I'm going to substitute it in. We have 2 times by 5 plus 8. And on this side we just have 20, so there's not really anything we can do there. And then I'm going to do this, I'm not going to do it as slowly as before. So 2 times 5 is 10, and then plus 8 gives us 18. We actually already did that before. And on the right hand side we still just have 20, there's nothing here. So when we work out what the right hand side and left hand side are equal to, we get 18 on one side and 20 on the other side. But this equation is saying, well, these have to be equal, they should be the same. So the value of x equals 5 does not satisfy this equation. I'll show you with another value. I'll show you with -2. I might stumble on the correct one. You might even know the correct one. So I'm going to be doing 2 times -2 plus 8. And that's on the the left-hand side. And on the right-hand side, we just have 20. Then 2 times -2 is -4, plus 8 is 4. And on the right-hand side, we still just have 20. So you can see when x is -2, this equation is not satisfied. The right-hand side and left-hand side should be equal, but they're not. There is one single number which satisfies this equation, okay? And today's lesson is all about finding that one special number that satisfies an equation. So, I'm going to need to turn over my page. Draw some margins just to make my work nice and neat. Okay. So the title of today's lesson is Solving Equations. Now, we're going to make a note of the fact that solving, this word, solving an equation, we're going to write down what that means. When a question asks you to solve this equation, what does that mean? It means solving an equation is the process you go through to find the single, so there's only one, the single value that satisfies the equation. And when I say satisfies the equation, I mean makes it true. Because remember, when we used -2 and 5 in the previous one, the equation wasn't true for that value. Okay? Now, when we do this, now this is really important, you might want to highlight this. We use a method to do this. Now this method is called the balance method. Make a note of this as well. This is called the balance method. And I'm going to teach you what the balance method is. It's really not too tricky. But I want you to think about what balance means. The word balance, we use it in lots of different ways. You might be thinking mainly of some scales. If you balance a pair of scales, you might have equal weight on both sides, okay, of the scale. There's the same thing on one side as there is on the other side. And that is the main idea with the balance method, okay? It's being the same on both sides. So we'll do some examples now. So example 1, we're going to be solving 2 equations together, okay? You might even want to highlight these things, you know, make them look nice, make them stand out, as they are very important. What solving means and the balance method. So anyway, example 1, we're going to solve 2 equations together. We're going to solve. I'm going to start to use different letters. I'm not always going to use X because, you know, there's many other letters in the alphabet that we can use, and there's many other letters that you will see when you are doing algebraic problems in algebra. So I'm going to decide to just use the letter A for this one. So this equation is A plus 8 equals 2.5, and we're going to do 2 together. and a take away 8 equals 2.5. So these are the two equations we're going to solve. We're going to look at this first one. I like to have some different colours available to show what I'm doing to both sides. Remember, the balance method means you have the same on both sides. So, and sometimes when I've taught this in the past, pupils will even, when we're talking about both sides, you might be thinking, well, both sides of what? We're talking about both sides of the equal sign, and some pupils that I've taught, they even draw a line where the equal sign is to make sure they do the same thing to both sides of it. So anyway, in this equation, a has 8 added to it, and we want to find what a is. Remember, solving an equation is finding that single value, finding what that single value is. Now, if a, our single value that we want, some pupils I teach even highlight the letter that they're looking to find. We want to find a, and a has 8 added to it. What I'm going to do is do the opposite of add 8. Now, the opposite of adding 8 is subtracting 8, and I'm going to do that to both sides of my equal sign. Now, on the right-hand side, because I have plus 8 minus 8, well, they will cancel each other out, and I'll just be left with my single letter a. Yes, great, that's what I want to find. And on the other side of the equal sign, I just need to work this out. 2.5 take away 8. Well, some of you will be able to do that in your heads, I'm sure. Some of you might not, so you can use some methods that we've learnt. So 2.5 take away 8. Well, one method we've learnt is the changing signs method, so we could change this to negative 2.5 plus 8. And then we could use the bubble method to switch these around. So plus 8 take away 2.5. That's going to be 5.5, but then we have to change it back because we changed the signs, didn't we? So negative 5.5. Oh, probably could have picked some easier numbers to work with, but hey ho. So negative 5.5 is what our letter is equal to. And remember, solving an equation is finding what that single value is. And we've done that. A is negative 5.5. That value, negative 5.5, satisfies this equation. Negative 5.5 plus 8 is equal to 2.5. It works. Okay, the next one. So in this one, we want to solve, which means we want to find the letter. And the letter is A. Now, in this case, A has 8 subtracted from it. And we just want to find A by itself. So I'm going to have to undo take away 8. I'm going to have to get rid of take away 8 by doing the opposite, which is to add 8. But remember the balance method, we do it to both sides of the equal sign. So on the left hand side, the minus 8 and plus 8 cancel, and I'm just left with A. Great, because that's what I'm trying to do, find A. And then on the left hand side, I have 2.5 plus 8, which is going to give me 10.5. So this is great. I've found what my letter is equal to. It's equal to 10.5. If I were to substitute 10.5 back in, 10.5 take away 8, it equals 2.5. So it satisfies that equation. So this is great. Now, I'm going to give you 2 to have a go at by yourself. The sun is shining there. I'm going to give you 2 to have a go at by yourself. So let's go with, we'll change our letter this time. B plus 1.7 equals 2. And we'll go with B minus 1.7 equals 2. So pause the video please and have a go at these 2 questions. Okay, get ready to mark these questions in a different colour. So I'm going to whiz through these. So for this one, I always like to highlight the letter that I'm trying to find. When we do harder ones, that will be useful to you. So on this one, I had to subtract 1.7 from both sides, and that leaves me with B equals 0.3. And on this one, I have to do the opposite of take away 1.7, which is to add 1.7, but I must do it to both sides because we're doing the balance method. So on this side we have b equals, and then we should have 3.7. So there we go. These ones are nice and simple. Right, we'll do example 2 now, so we just need some more space. We're going to be solving again. Going to be solving the whole lesson. So, example 2, we're going to have 17a equals 34 as our first example, and 200a equals 40. So, you don't see any additions or subtractions in these ones, and that's because they don't have additions and subtractions in. These problems contain multiplications, don't they? Over here, a, which is what we're trying to find, remember solving means find the letter, find what the letter is equal to. A is being multiplied by 17. 17a means 17 times a, right? So if a is being multiplied by 17, well, how do I undo multiply by 17? Well, to undo multiply by 17, we have to divide by 17. And I'm going to show that with a fraction like that. So when I divide by 17, on the left-hand side, well, the 17s will cancel, because multiply by 17, divide by 17 cancel, and we're left with a. Great, because that's what we're trying to find, isn't it? A single letter that satisfies this equation. That's what solving means. And 34 divided by 17 is equal to 2. So that value, a equals 2, satisfies this equation. 17 times 2 does equal 34. So we know we've done this right. The next one, a is being multiplied by 200. So to undo multiply by 200 and find a by itself, we have to divide by 200. That's the inverse of multiplying by 200. We must do it to both sides though, because this is the balance method. And on the left-hand side of our equation, our 200s will cancel, because times by 200, divide by 200, cancel each other out to give us just a. And over here we have 40 over 200. So I'm going to work kind of away from my main working out and just figure out what this is, because this fraction, I'm already looking, it can be simplified, right? I can divide through by 10 to get 4 over 20. And then I can also divide through by 4 to get 1 over 5. So I'm going to, rather than leave my answer as 40 over 200, I'm going to leave it as a simplified fraction 1/5. You might know what 1/5 is as a decimal as well, so you could leave it like that. But I'm going to leave it as a equals a fifth. Okay? And that works. If you were to substitute that in and do 200 multiplied by a fifth, you would get 40. Okay? So I'm going to give you 2 practice questions to have a go at. So I'm going to change up the letter. We're not going to use A or B or X. We're going to use F. Okay, so I'm going to give you 9F equals negative 4,869. Don't be scared of big numbers. You know how to do bust up division. And we're going to have 16F equals 4. Okay, so pause the video and have a go at these 2, please. Okay, get a different colour pen and mark your work. I'm going to whiz through these. So for this one we have to divide by 9 on both sides. That helps us to get this F by itself on the left hand side of the equation. And then I would use bust up division to do 4,869 divided by 9. So I'm just going to need to do that quickly. So 9 goes into 36 4 times. Oh, 9 times tables are failing me. 45. So that's 5, remainder 3, And then 9 into 36 is 4, and 9 into 9 is 1. Okay, phew, that was embarrassing. So, 541, but just remember we had a negative divided by a positive, which gives us a negative answer. So it's negative 541. So if we were to do 9 multiplied by negative 541, you can try it. You can use column multiplication. We would get this answer. And for the next one, we need to divide both sides by 16. And that would give us, on the left-hand side, we'd have f. And on the right-hand side, I'm going to give a simplified fraction. I'm not going to leave it as 4 over 16. I'm going to leave it as 1/4. So hopefully you've marked that in a different colour. We just have a couple more to do. So I'm going to need to go onto a new page. I know this video is getting quite long. So, okay. Blurry. So example 3, we're solving again. Perfect. Okay, so these examples, we're going to do 2 together. So I'm going to have, I'm going to pick a different letter because I keep using A. So this time I'm going to use G. And also what I'm going to do is write my equations like this. I'm going to have negative 3 equals G over 16. Notice, for this one my letter is on the right hand side of the equation. I'm trying to solve for G. And it's on the right hand side, but that doesn't make a difference. And the next one we'll do is we will have 4 equals 1/16 G. So for this first one I've highlighted G because that's what I'm trying to find. Now remember, solving means find the letter, find what the letter is equal to. So I'm looking at my equation now. G is being divided by 16. G is being divided by 16, so what's the opposite or the inverse of divide by 16 so that I can get G by itself? Remember, I want G by itself over here. Now the opposite of divide by 16 is to multiply by 16. And I must do that to both sides of the equation because we are doing the balance method. So, divide by 16 and multiply by 16 cancel out to give me just G. Perfect. And then 16 multiplied by negative 3, well, if I just do 16 times 3 really quickly, or I could add it up 3 times as well, that would be the same thing. I get 48. I do just need to remember though that this is a positive times by negative, so it's negative 48. And for the next one is a type of equation that confuses lots of people when they see a fraction, so here we've got 1/16, next to their letter. Now I'm going to teach you a really neat trick. I'm going to do this in a completely different colour to everything. Well, actually not everything, but 1/16 G, so this thing here, is exactly the same as G over 16. So whenever you see, I'm just going to copy down the equals 4 part. Whenever you see a fraction next to a letter like that, so 1/16 G, you can just put the letter up on the numerator there. So G over 16. Now this then is pretty much the same as this equation. We're trying to solve it, we're trying to find what G is. G is being divided by 16, so we are going to multiply by 16 to undo that and get G by itself, but we must do it to both sides because we're doing the balance method. So our answer then, well, multiply by 16, divide by 16 cancel to give us just G, and then 16 times 4 is 64. That one I just know off the top of my head. So I'm going to give you 2 to practice at. So the 2 that I'm going to give you are, I'm going to give you a completely different letter. You're going to have 1.1 equals E over 4. And I'm going to give you 9 equals 1/3 E. So pause the video now and have a go at these 2, please. Okay, get a different colour ready to mark. So we're trying to find E, trying to solve, which means find the letter. Now E has been divided by 4, so we need to multiply by 4 both sides. So that should give us, on the left hand side, 4.4, and on the right hand side we have E. So we have found that E equals 4.4. And if you substitute that back in, 4.4 divided by 4 does give 1.1, so you have done this correctly. And the next one, we remember that if we see a fraction next to the letter like that, we can just rewrite it as E over 3. So this is our equation, E over 3 equals 9. We're trying to solve for E. E is being divided by 3, so I'm going to multiply by 3 on both sides. And that's going to give me 27 equals E. Great. So 27 divided by 3 does give 9, so I have done this correctly. Okay, we're going to stop there.